Okay, I'm Adrian. Like you said, I'm from Chainguard, and I'm going to be talking about Wolfi, which is our relatively new Linux distro, and why we ended up building a Linux distribution. So what we actually want to build is secure container images. So like we're obsessed with creating container images with zero or very few vulnerabilities in them that are minimal and hardened. And to do that, we built a Linux distro. And yeah, on the face of it, that seems a bit crazy. Why do you need to build a Linux distro just to create container images? And so to really understand where this all came from, we've got to take a step back and look at sort of the state of the art in containers, or at least the state of the art prior to Chainguard. So about the most secure thing you can do with containers is use a scratch image. So if you have a Go application or something that can be statically built, there's a chance you can just create that binary and put it in a static image and it'll run. Now in reality, you'll find that most applications don't work this way because you typically need things like /home or /etc or /temp, or you might need users, and you won't have any CA certificates, so you won't be able to talk TLS and things like that. So for the majority of applications, you can't just copy something into the scratch image. You need a little bit more. And that's exactly where Distrus comes in. So Distrus by Google was a really cut-down version of the Debian operating system. They basically took everything out except what they needed to run applications. And the Distrus image ended up being much smaller than either Debian or even like the Alpine distribution. It doesn't even contain a package manager or shell. But the problem is there's a very limited number of Distrus base images. There's one for putting static binaries in. I think there's one for Java. There's one for Python, I think. And what they have is fantastic. But the problem is there's a limited number of images, and the images there are kind of hard to extend. Like it's based on Debian. So what you'd like to be able to do is say, OK, I want a Distrus base image, but I want to add a couple more deb files in. But in reality, it's not that simple, and you do have to play with Bazel. Which isn't something I enjoy. I do know other people here definitely like Bazel, so I will leave it there. So to give a bit of background, the people at Google that built Distrus, or at least two of them, are Dan Lawrence and Matt Moore. And they went on to found Chainguard, the company I work for, and Dan's actually a CEO and Matt's a CTO. So at Chainguard, they wanted to take Distrus to the next level and create a new version that was more extensible and maintainable. And to do this, they hired Ariadne Connell, who it sounds like one or two of you know. And she's from the Alpine project, or has a background in the Alpine project, and she's really been the force that's driven like everything we've done with Wolfi and Chainguard images. So I really want to give her a large shout out. And hopefully, like in next year or something, maybe we can get her to do like a much more in-depth talk. But one of the first things that Ariadne did was to build a tool called apko or Appco. I don't know, I end up pronouncing it different ways on different days. But what Appco does is it just takes a bunch of APKs, which is the Alpine package format, and bundles them into an image. So it's really pretty simple. It is, I suppose, equivalent to Docker build, but it's much, much, much simpler. You don't get run statements. You don't have a build context. Everything's completely declarative. It's designed to be reproducible. And the reason, it's kind of easy for us to be reproducible compared to Docker build because it's so much simpler. Yeah, and it also makes it easy to build images that don't have a package manager or a shell because we do all the package management outside the container image, if that makes sense. It looks kind of like this. Well, not kind of like this. This is an example. So this is using, we're saying we want to use the Alpine repository, and we want to install these packages. And that's pretty much it. Obviously, there's a little bit of metadata. You might also want to set on container images like entry point, users, things like that. OK, so Appco gives us the ability to create minimal Alpine-based container images. But we still need a way to create our own APK packages for applications, that we create. And that's why we created something called melange. So what melange does is build APKs. We could have used the Alpine build tools and perhaps adapted them, but instead we created something new. The reason being the Alpine build tools are all kind of shell-based and served a different purpose. We wanted something that was more modern and kind of crucially was pipeline-oriented. So when you see melange, you'll see like multiple steps in a pipeline. And it's inspired by stuff like GitHub Actions, and it's also kind of designed to run in systems like GitHub Actions. These are a bit bigger. I'm going to try clicking on this. This might ruin the presentation. Where's a mouse pointer? I wonder if this is a bad idea. Yeah, so this is an example. It's maybe slightly small to read. Can I? I'm scared to hit Command+. There we go. Yeah, so it's fairly simple. This is on the Wolfi at the minute. This is a melange file. It's built in libaio. What you say is that this environment sets up the build environment, so it's the packages you need to build it. And then we have pipeline. First step in the pipeline is, unsurprisingly, download the source. Then we're going to call make. This is actually a pipeline version of make, so there'll be some more arguments hidden in there. Make install, strip the binary to make it smaller. And you can also pull out stuff to sub-packages. So there's a libaio-dev sub-package, which will pull out the headers for libaio. If I can manage to scroll down. There's also, we have some extra metadata that's used within our own systems for automatic updating. And if time, I'll explain a little bit more about that later. Wait, what's back? What's the command for back? Oh, that one, OK. Oh, that didn't work. What do you reckon it is? Left arrow. Maybe. Oh, the Chrome. Is that what you mean? How do I go back? I'm hitting left bracket. I shouldn't have clicked this, should I? See, I tried it. He thought I hadn't tried it.
No, I don't know.
I think it's because you're in the editor. Oh, OK. Make it big again. It's all right. We'll get it. Don't worry. Oh, it's because I'm in a new tab. See, computers. I'm not going to click the next example. They're all pretty much the same. Oh, cool. Right, I'm not clicking that. OK, so with melange, we basically had the ability to create APKs in a scalable and maintainable fashion. And at this point, you start thinking, well, what is a Linux distribution, and how far does melange get us to building our own Linux distribution? And the truth is, like Linux distributions, when you think about things like Red Hat and Ubuntu, they've been around for decades. They're really built in a time when you had like servers and floppy disks or CDs to install them. And OK, VMs came along, and that didn't change things too much. But now we've got containers, and that kind of did change things quite a lot. Because now in a container, you typically run one application. You don't run a whole suite of applications. And things like static binaries tend to be a better solution than shared libraries, for example. So we realized there's a lot of advantages to being able to rethink what a distribution was. And also at the core of a distribution is really packages, like package management and distribution. And that's the part that we had. But honestly, I think a large part of it was just we wanted to see if we could do it, or Ariadne wanted to see if she could create a new Linux distribution and how hard it would be. And so Wolfi was born. Wolfi is so named because like the Chainguard logo is an octopus. Wolfi is the world's smallest octopus, I believe. We sometimes call it an undistro rather than a distribution. The reason being that we don't have everything associated with a full distribution. Most notably, there's no kernel. So we rely on like the container host to provide the kernel, for example. Everything in Wolfi is compiled from source, but unlike Alpine, we use glibc. And although we use Alpine's APK format, you can't mix and match like Alpine packages and Wolfi packages. They're completely separate, mainly because of the glibc versus muzzle thing. Where possible, like our sources are bootstrapped, so there's like a really nice blog on how we created our Java compiler. We went back and you have to bootstrap with older versions of Java way back till you get a version that compiles with C. So what were the benefits here? I got this picture this morning, and it was meant to be like victory, and then I realized that the kid just wants picked up. But anyway. But one of the major benefits when we created Wolfi was that we had APKs, but compiled against glibc. So we don't have some of the issues that Alpine has, where people complain about muzzle, which is never muzzle's fault, but people still get upset about incompatibilities. But perhaps the biggest advantages were that we could now control how quickly packages could be rebuilt and built into Chainguard images. And we can also issue security advisories for our packages. And to understand why these things are critically important for what we do, we need to take another step to the side and look at vulnerability scanners. So I'm guessing most of you have probably used containers. Have you used like vulnerability scanners like Privy or Gripe or Sneak or now it's Docker Scout now? Do people know what these are? Some do, most do. And basically, a vulnerability scanner will look at your container image, make a list of all the software inside them, which may sound a little bit like an SBOM, and compare that list to various security databases and return any known vulnerabilities. And on the face of it, this sounds amazing. Like theoretically, I can look at my image, find any vulnerabilities, fix them, and push to production vulnerability-free. But in reality, it is not so fun. What happens is that nearly all public images have vulnerabilities. And that's because the base images they're built on have vulnerabilities. And there's not much you can do about it. OK, so I reran this again this morning. So if you run Gripe, which is a vulnerability scanner we use quite a lot internally at Chainguard, if you run that on Redis, what you find is the following results. It's claiming there's 7 critical, which seems high. I suspect there's a lot of false positives there. But also note there's 109 packages in there. So there's a lot of software in this image. I should say, like this is Redis colon latest. And that gets you the version based on the Debian base image. If you change to the Alpine version, things get a lot better. And I ran it this morning. There was only 2 matches. They're classified as unknown. I wondered why that was, so I went and looked it up. It's because NVD hasn't assigned classification to them yet. But yeah, one key thing to note here is there's only 19 packages. And so there's a lot less software in this Alpine image than there is in the Debian image. And that's one of the reasons there's less vulnerabilities. Compare that to the Chainguard version, and there's 0 vulnerabilities. We seem to have more packages. I'm actually not quite sure why there's 34 packages. There used to be 20. But there's still a lot less packages than the Debian version. So how did we get there? As well as having a smaller image, there's a couple more things. If you look at the Debian and Alpine the update cycle to create a new image based on a Debian or Alpine base image, it looks like this. If there's an upstream project releases a new version or releases a patch, Then Alpine or Debian has to find that update, has to create a new package based on the updated sources, and then the distribution, and then Docker or official images or whoever's building the image has to build an image based on that new version. And what you find is there's a 1 to 2 week lag between a new version coming out of the upstream project and the official image being updated. But because we control Wolfi, the Linux distribution, and creation of the Chainguard images, we can reduce that down to an hour in some cases. So between like an upstream project releasing a new version and us pushing that new version out as a Docker image or a container image, we can get that down to a day or even an hour in some cases. So that's a huge benefit of running our own distribution. The other point is around patching and security advisories. So sometimes upstream projects don't do a release in response to vulnerability being found. And typically, one common case for that is because the vulnerability is in a transitive dependency. So it's not in the project's code, it's in a library they've pulled in. And so what we all need to do to get rid of that is to pull in the code, update the dependency, and create it, rebuild it based on that new version. And the problem here is we need to be able to tell scanners that we fixed this vulnerability, because we'll still be running the same version of the code, so it's still version 2.0.4 of whatever the software is, but our version is fixed and the upstream isn't, sort of thing. So to a scanner, if they say 2.04, they're going to naively assume that it's vulnerable. And this is where security advisories come in. So this is from a couple of months ago. I ran a scan on the Alpine Redis image, and this is what I got. What I want to note is these two critical vulnerabilities, and one of them here is 22.0543. And these didn't turn up at the time in the Chainguard image, which had 0 vulnerabilities. And the reason was they didn't turn up in Wolfi comes down to security advisories. So these security advisories are just basically YAML files that the scanners pick up. And you can go and see all the Wolfi ones here. I'm definitely not going to click on that link. But what you'll find if you go there is something like this. So this is the security advisory for Redis, and this is the advisory for that critical vulnerability. And we say it's fixed, and it's fixed in this version, and the timestamp, etc. Now, I think at the time I did look into this, and the vulnerability was something related to a certain distribution's packaging. So I'm sure the Alpine version also wasn't vulnerable to CVE. Well, it wasn't Alpine. I'm sure the Docker images version also wasn't vulnerable to the CVE. But the thing is, they hadn't installed Redis via an APK. What had happened with the Docker build is the Docker build had downloaded Redis and built it and installed it that way. Which is fine, but the problem then is, the vulnerability scanner has nowhere to go to look for security advisories. Because you can't look at the Alpine one because it's not installed via an APK. So the Alpine package is completely different. So basically, Docker had no way to say, this vulnerability doesn't affect this image. So that's why it's really important for us to have our own Linux distribution and be able to issue advisories like this. Yeah, so to recap, the reasons that the post hoc reasons that we love Wolfi is that we started it because it gives us a glibc-based composable package system that allows us to make our minimal distroless images. But we also got the sort of fast update cycle and the ability to issue security advisories. I'm not sure we realized at the beginning how important that would be. Okay, how am I doing for time? Okay, so I added a few slides on the things that have come up at this conference already, and that I think you'd be particularly interested in. So one thing I mentioned earlier was reproducibility. Things being reproducible in the sense of if I do things twice, I get exactly the same thing down to the bit. Has some really nice properties for security and debugging and things like that. And that's exactly what you get with Appco. So in this example, I've run Appco build on this Appco file. It generates an SBOM, which I'll talk about in a sec. But I can run shasm on that file. I get this out. If I delete it and run it again, I get exactly the same SHA. So I end up with exactly the same artifact. And to do that, you do need to do a few things like control timestamps and so on. But because our build tool is much simpler than Docker build, it wasn't really that hard. If you try and do something similar with Docker build, you'll find it very difficult. It's not impossible, but it is very difficult. The other thing, automation and updates. I'm not sure if we underestimated it, but certainly running a Linux distribution and trying to keep stuff up to date is a lot of work. And we have to automate. We're a small company. We have to automate as much as we can. So we use stuff like release monitoring, which is a Fedora project, to tell us when a new version of a project has released an update, and also GitHub. We use the GitHub releases stuff extensively, and we actually prefer that to release monitoring because it gives us a bit more metadata, things like the expected commit and release notes that we can lean on. The way we do that is at the bottom of our melange files, we have something like this. So this is just telling me that for whatever project this was, you want to run a cron job against this release monitor ID. And very similar, we have one bit for GitHub. We can do some futzing around the tag name to try and pull the version number out. Oops. Oh, no, I'm sorry. So yesterday, in the first presentation, this point was made about creating SBOMs. So at the minute, a lot of the tools that are used to create SBOMs look at the package manager results and try and create an SBOM for a container image after it's been built. But at that point, you've already lost a lot of data. And that was kind of the point being made in this slide. You're much better creating an SBOM at build time when you have all this data you can put into the SBOM. And that's what melange and apko do. So when we build an APK with melange, we create an SBOM. And when we assemble that into a container image with apko, it pulls in all the SBOMs from the melange files. Yeah, that's pretty much what I want to talk about. So basically, we built Wolfi because it seemed like a good idea at the time. And actually, it turned out to be an excellent idea and really drove our product Chainguard images forward. So while Chainguard images is like our commercial product, Wolfi is most definitely like a community project. And we would definitely like to get, at the minute, it's mainly us, but we would definitely like to get collaborators and people working with us on Wolfi. So if you're interested, please do go out and check out wolfi.dev. Okay, thank you.
Questions? OK, Danny is very enthusiastic for questions, so I think I'll go back here. Seeing no other hands.
Hello. I know this is not going to be a direction for Chainguard, so I'm not asking about that. But this is one of the things that you mentioned about melange specifically is that it allows you to make changes to software, it allows you to make patches, et cetera, and obviously it gives you the metadata as well. I'm wondering, so this is not about the metadata part, but rather as an example, and again, I don't think this is a product direction for Chainguard, but as an example, do you think that the flexibility that something like melange or your other tooling gives you would be would it make something like replacing glibc with muscle easier potentially? And I'm asking because I would love to have this working in SPAC, which I think has some vaguely interesting capabilities to melange, and I've talked to Ariadne about that. So again, I know this is not a product direction, so I'm sorry if this is annoying, but I'm wondering, is this the kind of, I think, thing that melange maybe would also be helpful with? To me, it seems like the case, or the rest of tooling as well.
So I can hear you too clearly, but I think the question is, would melange be useful, or did melange help us move from muzzle to glibc, or?
Would it make that replacement easy? And again, I'm not asking if this is a good direction for Chainguard, but I'd love to know if I guess, whether that's more difficult than others, or I guess your system is about packages as opposed to these really, libc is a basic thing.
So I've not, this is my only experience of creating a Linux distribution, I suppose most people's, but the thing is, when you create a Linux distribution, you have to start right at the top and bootstrap things. And glibc or muzzle is one of the first packages you have to create. And then everything else flows from that. So the problem is just like the time it takes to build all the packages against each other, and you have to redo everything if you change the fundamental library. But yeah, it's certainly possible. And if you don't want that many packages, it wouldn't take that long either. And one thing I didn't touch on is that multi-arc, like melange also has a lot of support for multi-arc. We only build AMD64 and ARM at the minute, but there's definitely support there for adding other architectures.
Any other questions? Yep.
Thank you. So I wanted to know whether you are or hope to be a member of the MITRE scheme, in which you can publish your own CVEs directly, and if not, who else you apply through?
I don't know too much about MITRE. Like our Dan and other people within Chainguard are heavily involved with and comment on everything involved with CVEs. So I don't have a good answer for you, I'm afraid. You'd have to ask Dan Lawrence. Ask him on Twitter.
Okay, others? Let's see if I can.
Hey, I wonder how reproducibility works with the security updates. If you build an Appco image and then there comes a security update and then you build it again?
I think, I'm not 100% sure if I'm going to answer your question properly, but so I said it's reproducible, and that does work. Like, if you run this twice, you will get the same thing out, with a big caveat. The caveat being that these packages haven't changed. So if these packages, and you can pin packages with an equal syntax, but if these packages change, then your final image will change. Really, you want to, one thing I like to work on is like a completely hermetic build where you give it all the inputs and it doesn't go out to the network or anything. And that's certainly possible. And then, you'd have something hermetic and completely reproducible. Because although I said, in 6 months' time, you will not end up with the same image if you run this. Does that answer the question or not? Oh, it does, okay.
Okay, so let's thank our speaker one more time. Thanks, Adrian.